OK, so the next presentation is about grids and clouds. So I introduced the clouds this morning, right? And here is essentially the slide that I showed you. And to a large degree, clouds are really a mix between grids and hosted computing, because you still have jobs, but they are virtual machines. They are not just regular user jobs. So here is a more detailed comparison between the two. And the main difference is what you ship as a job when you run in the cloud. Instead of having your shell script or your binary, you have to ship the whole system image, which includes the operating system itself. And this gives you lots of flexibility and adds a lot of complexity. The other thing that a lot of clouds propose, and it's arguably one of the reasons why they were so popular, is because you actually give a dollar value to the resources. So in grids, you typically just submit for free, and you just wait until you get something. You don't really pay for what you're using. Most of the clouds actually have a dollar value. You actually have to take out your credit card to use it. And the third one is the instantaneous access, at least up to the point, where because you are paying for it, whoever is providing cloud resources usually has good incentive to start your resources fast. So there is really no queuing in the cloud environment. You either get the resource or you don't. So while in the grids, you may sit in the queue for days, in the cloud, if the cloud provider cannot give you a resource within minutes, they will tell you. They will tell you, I simply don't have them. Go away. There is no queuing, really. So I'll go over all of this in a relatively random order. And I will stay with the pay to use. As I said, Amazon made cloud computing really popular by defining a price of the computing per hour. You need one CPU. It's 8.5 cents per hour. Very well defined. And the other selling point it was, because they were selling it, is that you get the resources immediately. As I said, no queuing. And Amazon can do this because they essentially keep a certain amount of machines unused all the time so that they can give you your instant access. This is quite different than what we try to do in the grid when we try to keep all the machines busy as much as possible. And this is the whole reason why we have batch system, right? And we are not just interactively logging in. The instant access, it's almost like interactive login. You either get in or you don't. However, even Amazon realized that this is not such a great idea, because keeping some machines unused, it's a waste. Wouldn't it be better if somebody paid for those unused resources? And they come up with this idea of spot pricing, where essentially you can bid on the machines that are sitting there in reserve. The catch is that the moment somebody else bids a higher price, possibly the full price for the instant access, you're kicked off. This gets now much more closer to the high throughput computing we have seen until now, where you try to keep all the resources busy all the time, but if you have to kick somebody else to get the higher priority job in, you do. The difference is that Amazon uses dollars instead of priority that you have, for example, in Condor. But apart from that, it is getting conceptually very, very close. So the other big thing is that you are shipping the whole images. And it's arguably why the second pillar why Amazon was so successful. Because, face it, scientists are the minority of the computer users. Most computing these days are either gamers, but those are not interested so much in the cloud computers, or they are businesses. And businesses don't run scientific jobs that run days. All they care is web services and databases. So most of Amazon resources these days, it's used to host web services. And to do that, you actually want to install everything from the bare metal up or close to it. And it works pretty well in virtual machines. For scientific uses, I would claim having the whole virtual machine is less important. To a large degree, many scientific workloads run pretty well on a lot of platforms, and you don't need root access. You just need something that, an environment that supports your application, but you don't want to tweak the driver in order to make it work, right? It is still a nice to have feature because it makes life much more organized, much more uniform. So having all Red Hat 5 is better than trying to run between Red Hat 5, Ubuntu, and Windows, and some Solaris. But most scientists probably could adapt. So I would argue that, yes, having virtual machine is nice, but it's not essential for us. While for businesses, it's a deal breaker. Either you give me the whole machine, or I'm not interested. But this also means that you have to create your virtual machine if you use the cloud. And you can do it yourself. Or if you use a pilot, the pilot does it yourself, and you can then run your job. And this is why I'm saying you may not care to be able to provide the virtual machine. You may just want to run your job and make sure that somebody actually started the virtual machine with the environment your jobs can run in. And then all you need is a client to be able to submit, and here we go. So the clients, as usual, you have the native clients, and depends where you go, but pretty much everybody standardized at least on the protocol, which is EC2, and then you have different implementations directly for Amazon, the Eucalyptus, the OpenStack, Nebula. The cloud is so popular these days that essentially everybody and his son writes a client for it. But you can also use CondorG, unsurprisingly. CondorG is a Swiss knife. It can do everything, including submitting cloud to the cloud. Or you can go with the overlay system. Client WMS has some prototype support in it, and hopefully in the future we get some more. I'm not sure what support is in Panda. I know they were working on it, but I don't know if they are there yet. And there are some commercial things, and one of these is Cycle Cloud that we will concentrate today, simply because it's easy to use. So what is Cycle Cloud? Cycle Cloud, it's simply a service that will start a Condor cluster on top of Amazon EC2. It's a service run by Cycle Computing, which is a company, commercial company. All they want is your money. So literally, you go there, you give them some money, and they will do everything else for you. And once the submit virtual machine is started, you can log in and submit. So what you do, you talk to Cycle Cloud. Cycle Cloud goes to Amazon, starts the collector and the SCED. At that point, they will also get some glidings in, the SCED, the stardis, that will start to talk to the collector. Everything is running in the cloud. Now the user logs into the SCED machine, and you have your dedicated Condor cluster running on top of the cloud. Easy. And I have a demo about this. And as I said, the cloud is instantaneous up to the point. And when I tried it the past few days, it takes about half an hour to get everything up and running. So I will start the demo, show you what's going on. And while we wait for the cloud to actually give us the famous instantaneous results, you can continue on the other exercises. But bear with me for a moment while I show you how the Cycle Cloud works. So let's get this up. It's annoying, but that's fine. My Cycle Cloud. Okay. So it's a web service, and I have set up an account. I have bought $30 worth of credits from them, and I used a few just for testing. And I did the initial setup to say, I want a cluster that is called OSG-edu, and all I need to do now is press start. It tells me how much it will cost, how long it will take to get my schedule and collector off. I click OK, and I wait. That's it. Everything else will be completely automatic. So let's wait the 15 minutes. And as soon as this is running, I will let you log in and try it out. In the meantime, continue your gliding exercises from before. It's a completely independent system, so it will not, the two will not interfere with each other. OK, so our cloud schedule has started. So now, if we click here, it tells us what is the node. So this is the node to log in into. So let's see. And here we have the credentials. I cannot show both. So let me open a new window. And so you can see both. So this is the username and the password that I set up long ago. And I know that I should not, in production, show you what it is, but this is just an exercise. So, oops, stopped? What do you mean stopped? I never stopped it. Ah, no, yeah, it was just a quirk. So try to log in into this node and use this username password. In the meantime, I'll continue showing it. But in the meantime, I'm starting a few nodes because it will take another 15 minutes to get the execute node started. So I ask for 5 small ones. Yeah, let's just start node. OK, let's just keep with the small ones. OK, I ask for a bunch of worker nodes to be started. But in the meantime, try to log in into this machine. That is the username and the password, and see what is there. M11 OSG-edu, yeah.
Do you also have the address to?
Yeah, you don't see it? OK. Copy. OK, is it better to read right now? Should I make it bigger? So we managed to get all of our 24 worker nodes up and running. Yes?
So we looked at how we can use cloud run to use it as an HTC system. Can you share some points on how we can use an HTC system, a cluster as cloud?
Oh, you want to do the way around. You want to create, you want to offer cloud resources. Well, there are several options. You could use Condor. Condor supports the virtual machine universe, where you just create your virtual machine and submit it to Condor, and all you have to change is universe is virtual machine, or whatever it is called, and the executable is the virtual machine instead of executable. And it will just pretty much just work. I don't know how reliable it is, how well it works, but it is there and you can use it. Most people use EC2 compatible systems, and the two mostly talked about. So you cannot use the Amazon EC2 because they don't offer it. They keep it in-house. But the protocol is public, and there are several implementations. And as I said, the two most used, as far as I know, are Eucalyptus and OpenStack. So you can try to use them. I have no experience with them. I know people have used them with varying levels of success, I must say. But they do work to a certain degree, and they provide an EC2 compatible interface.
Are the protocols sloppy?
No, it's the implementation that is sloppy, not the protocol. So the protocol is exactly the same as the one Amazon uses, which works very well. But the implementation is so-so. So if we don't have any other questions, I will shut down our cloud pool. If you haven't logged out yet, you will be kicked out. And stopping paying for Amazon is as easy as click stop. Yes. And it takes a minute or so, and we should. They are stopping them. And come on. Stop, stop, stop. Oh, come on. Stopping should be fast, right? Right. And we are down. And we can see how much it cost us. I think it was, I used $2.6 before, and now we are at 4.9. So this exercise cost us just a little over $2.50. Not too bad, right? It's acceptable for pretty much any standard. Of course, we didn't do much, but still, we used, and we actually overpaid because Amazon charged you by the hour, and we haven't used the whole hour. So we could actually have run for another half an hour for free. We effectively wasted half of that money because we didn't use it fully.
Is this charge after starting up, or?
The moment you ask for them, it starts charging it. So the moment you ask for it, it charges you for an hour. And the next hour starts after an hour you have been using it.